Alright, two more FRQs. This is one of the classic. You got a graph, and they say it's a graph of g, and f is the integral of g, if I'm not mistaken. Derivative of the function, yeah, so derivative of f is g, so we're looking at a graph of a derivative. And then they say f of 1 is 3, what's going on? So they basically set us up here at f of 1 is 3, and they want to know what f of negative 5 is, so we have to go to the left. And above the graph to the left is negative, below the graph to the left is positive. So part A, if f of 1 equals 3, and we want f of negative 5 is integral from 1 to negative 5 of g of x dx plus 3, something like that, equals negative 1/2 1 times 2, that's this piece, nothing for this piece, and then plus 1/2 1 times 3, and then plus, and I put a 1/2 here the first time I did it, I have no idea why, 3 times 3, and then the 3 that's right up above. Blast it all out, you should get 25 halves. I apologize, I have a very runny nose. I'm having a bit of an allergic reaction to something right now. So then it says evaluate integral from 1 to 6 of g of x, which seems weird because it seems like the exact same question. But okay, whatever. Not the exact same question, but like they're asking it twice. So that is starting at 1 and going to 6. So we have this. And notice they're not asking for f, they're asking for the integral, so we don't have to add the 3 in. So we get a 2 by 2 part. And then we get the integral from 3 to 6 of 2x minus 4 squared, quantity x minus 4 squared dx, which is 4 plus 2/3 x minus 4 to the third, 3 to 6, which is 4 plus 2/3 8 minus negative 1, which should get you 10. Yeah. Then we get one of the classics, the mean value theorem. No, not yet. That's coming up later. Sorry, getting ahead of myself. So it says negative 5 to 6, open intervals. Oh, hey, that's kind of a giveaway, isn't it? I've been arguing about open versus closed. So we want increasing, which means that g of x is greater than 0, and we want concave up, which means that slope of g of x is positive. And if you look, you'll see that from 0 to 1 right here, and 4 to 6 right here, above the graph, and both increasing. So we get 0 to 1 and 4 to 6. And last but not least, find the x-coordinate of each point of inflection in the graph. My brain just shut down for this, and yeah, I got no good explanation for this. It's at here, x equals 4. So it is the point takes place where the first derivative changed from positive to negative. In other words, g of x goes from positive to negative. And that happens at x equals 4. That's it. It could be from, actually in this case it's negative positive, or negative to positive. G prime of x. It's embarrassing that I forgot to write that in. Or the slope of the derivative goes from positive to negative. Alright, classic table. And we just did integrals, so I'm going to go out on a limb and guess that we are doing a derivative kind of problem. Not completely, not totally, but derivative-ish. It says use the data to estimate h prime of 6. H prime of 6 is going to be h prime of 7 minus h prime of 5 over 7 minus 5. I've got units, so be real careful. And I would write them out. Meters per year. And h prime of 6, they ask us to interpret the meaning, is the approximate, because we did approximate it, approximate rate at which the tree is growing. At t equals 6 years. Hopefully not too much to write, but it was a bit of a mouthful. Alrighty. So, explain why there must be at least one time. So let's pick a spot that's nice and clean. One time between 2 to 10. I like 5 to 3 because we can say h prime of 4 is approximately 6 minus 2 over 5 minus 3, 2 meters per year. And use traps, no, explain that h prime of t equals 2. And I would not actually use that. I thought that was the one I was told to use. Let's try this. 4.5 over 3. H prime of 3.5 is approximately 6 minus 1.5 over 5 minus 2, which is 4.5 over 3, which is 1.5 meters per year, along with part A. Slope goes from 1.5 to 2.5. So the mean value theorem, I would spell this out, tells us h prime of t is 2 at some point. Again, apologize for the runny nose, just jumped out of nowhere. Use a trapezoidal sum with 4 subintervals, blah blah blah, 2 to 10. So it doesn't say just add it up, it says what's the average height. Average height 1 over 8 times 1/2 times 1 times 2 plus 1.5 plus 1/2 times 2 times 6 plus 2 plus 1/2 times 2 times 11 plus 6 plus 1/2 times 3 times 15 plus 11. Use a calculator. I'm astonished that they're asking us to do this with a fraction, but if you do, you should get 263 over 32. And it says the average height, so that's meters. And then finally, they do the classic. Let's throw something else in from the middle of nowhere. Hey, here's a new formula, and it's the height of the tree. G of t, they call it x, equals 100. That's nice of them call it x, so you forget that you're talking about time. X is the diameter of the tree, blah, blah, blah. It's growing at 0.03, blah, blah, blah. What's going on when the tree is 15 meters tall? Rate of change of height when the tree is 50 meters tall. Well, that means that we need to find out g of t here. G of 50 equals 100 time. No, that's 50. So they give us that height. $50 equals 100 x over 1 plus x, cross multiply. 50 1 plus x equals 100 x, divide by 50. 1 minus x equals 2x. I feel like I've made a mistake. That is indeed a plus. So 1 equals x. So this is at t equals 1. So, little derivative time. G prime of x equals low d high, high d low. D high minus high d low over squared times dx dt. Are they giving us a rate? Meters per year, dx dt. So that is the base of the tree. Diameter is given per the height. Okay, so this is 0.03. This gets real fancy and changes. We end up with 100 plus 100x minus 100x. We just get 100 over 1 plus 1 squared. 2 squared is 4 times 0.03 gets us 0.75 meters per year. Apologize for not doing the greatest job in the world. Kind of hard with the runny nose, but I had to get it done. So that's it. Complicated, not easy. So hack away at it, you'll get there. Good luck.